Autumn in Michigan, crystal clear skies, colorful leaves, clean air, and heating season. The ubiquitous programmable thermostat from the big box stores. Mom pushes the up button, Dad pushes the down, because Mom wants the heat and Dad wants to save money. Understandable. They work. Many people have converted to Wi-Fi enabled thermostats, which makes it even more convenient to control from a distance. But neither one of these will solve every problem. They may make a small improvement, and they certainly help to automate the setbacks. A simple heating system is a furnace and ductwork to distribute the air. Simple enough on the surface. Enthalpy is what we're after, though. It's the heat in the room. And that has three elements. There's the total system energy, plus the quantity, pressure times volume. Now, assuming that the furnace is converting fuel to heat, air movement is the other element. So we have to check the blower. Is the blower running? If it is, then we must have pressure, at least at the plenum. But that doesn't mean we have volume. Volume may be a problem if the system is restricted. Now, restrictions can come from a couple of different sources. One is perhaps a dirty air filter, or one with a too high a MERV rating for your system. I use a MERV 8. One way to tell is to pull the filter out and see if the airflow increases substantially. Another source of plugging may be at the registers. I've found it full of stuffed animals and dump trucks. In a properly functioning system, we find the furnace producing hot air, and it blows that hot air through the ductwork into the living space, whereupon it warms the living space as it circulates through that room or rooms. It comes back to the furnace through the ductwork to be heated again. Does that mean the living space is perfect? No. It can have cold spots because of windows, which honestly, if there are two, they're doing pretty well. Older windows have an R1, 1.5. Replacing a window may not get you anything substantial in terms of comfort, but it certainly will be costly. So the thermal gradient is one reason. From floor to ceiling can often be several degrees F, and it may not be circulating long enough. An example is an oversized system. If the furnace is too big for the space, it's going to short cycle. It'll satisfy the thermostat by providing heat quickly, but the fan doesn't run long enough to circulate the air throughout the room and make the whole building comfortable. In reality, what happens in most buildings, especially residential buildings, is that we have leaking ductwork. And the hot air enters the trunk above the furnace through the plenum and then leaks into the basement, whereupon it gives up its heat to uninsulated masonry walls, concrete floor, and gets sucked into the returns through leakage to be heated again and circulated again in the basement. That's all waste because it hasn't gotten to the living space, and it's not really warming up the basement because of the uninsulated walls. So if air is leaking in the returns, whatever gets sucked out of the basement is not getting sucked out of the living space. So that air has to have some source, and the common sources are open stairwells, and even stairwells with doors, because a door on a stairwell is unsealed, right? It's an interior door, so it doesn't need to be sealed. But if the ductwork in the basement is leaking, it creates a small negative pressure which sucks that cold air off the floor, down the stairwell, into the furnace to be circulated, and it never quite makes it across the whole room to the return air grill. So leakage is a huge problem in most systems. It results in uncomfortable rooms and high heating costs. Here's an example. Now this is a replacement furnace. The transition on the bottom is brand new, meeting the old return at the top. The locks are in place, but you can see the leaks. And the inspector looked at it and approved it. Didn't need to be sealed, apparently. Now, on a new system, it does need to be sealed, certainly. But apparently, given this approval sticker, replacement system does not need to be sealed. However, there's always a benefit to sealing. Now, even on a new system, it may appear to be sealed, but HVAC contractors seal after the ductwork is in place. They almost have to, because the ductwork has to snake around immovable objects. So they seal after the ductwork is complete. Now the inspector may see all the tape on the bottom, but he can't really see the tops, nor can he see where the ductwork goes through walls. So how do you know if it's been sealed? Chances are it needs a little more sealing. Perhaps on the tops of the trunks where they're easy to get to, or maybe they can be sealed internally using a process or product called AeroSeal, and there likely are more interior seal systems available now. But AeroSeal is quite effective for sealing all those small leaks that you can't get to with tape and mastic. Sealing those joints should never be done with duct tape. Duct tape is probably the worst thing you can use on ductwork because the adhesive dries out over time, it turns to powder, and the tape falls off and you still have a leak. By all means, use a tape that is designed to seal steel ductwork. And when it's sealed, it should look something like this. Every joint, every place where steel meets steel should be sealed. All of it has to be sealed, no matter how small the joint appears to be, because they all leak and they can add up to very big leaks. And when done, you will have a more comfortable living space. Yes, there will still be stratification. Yes, there might still be some cold spots, but all, if at least most, of the heated air makes it into the living space and back through the return ductwork where it belongs. You'll still have stratification going on, but the air will be circulated far, far better, and this, for the price of a roll of tape, results in more comfortable living space and lower costs.